Hello everyone, I am Balaji Rao. Welcome to BR Max class. This is first class of linear inequalities. Linear inequalities is the chapter we use very frequently in mathematics. This inequality symbols not only in this chapter, we use this everywhere in max, less than, greater than, less than or equal to. This chapter plays very important role in mathematics. And when it comes to this chapter is easy or difficult, this chapter is very easy. When it comes to theory, very limited theory is there. In this total 3 rules are there. If you know rule number 1, rule number 2, rule number 3, then you can do complete linear inequalities chapter. I am not saying first exercise. Complete linear inequality chapter you can do. In this class, I am going to explain those 3 rules. Before going to start this video, please drop a like for this video. Without much delay, let's begin the class. First, we will learn what are symbols of inequality, and we will learn what is the definition of inequality. Next, we will learn what is linear inequality. These are the symbols of inequality. This is less than or equal to, greater than or equal to. These are the symbols of inequality. If you take two numbers, which number is smaller, which number is bigger than other number, to tell we'll use these symbols. These are known as inequality symbols. What are the symbols of inequality? Less than or equal to, greater than or equal to. These are the symbols of inequality. Now we will learn what is definition of inequality. You observe this is the definition for inequality in Ncert textbook. Two real numbers or two algebraic expressions related by the symbol less than or equal to, greater than or equal to forms an inequality. What they are saying? You take two real numbers. They are related by these symbols. What are these symbols? These are the inequality symbols. Forms an inequality. I'll try to explain. First, I'll take two real numbers. I'll relate them with these symbols. Okay, you take here 10, 5. How you can relate these two numbers with these inequality symbols? 10, 5. Two numbers are there. Clearly, 10 is greater than 5. So we will write that greater than symbol. 10 is greater than 5. So what is this? This is one inequality. Two real numbers related by the inequality symbol. Here greater than symbol. Okay. Now I'll write one more inequality. You observe I consider two real numbers minus 2 and 3. These two real numbers are related by what symbol? What is the relation between these two numbers? Minus 2 is smaller than 3. So I'll write less than symbol. Minus 2 less than 3. Minus 2 less than 3. This is inequality. Here you observe I explained with two real numbers. Now I'll explain same thing with two algebraic expressions. You observe here x square plus 4x is greater than 2x. You observe here this is one algebraic expression, x square plus 4x. 2x, this is one algebraic expression. These two algebraic expressions related by inequality symbol. Here I written greater than inequality symbol. This is one inequality. Two algebraic expressions related by these symbols forms an inequality. So this is one inequality. Now I'll take another two algebraic expressions. 2x plus 3 is greater than or equal to 5. You can observe here this is one algebraic expression. 5 is also it's a constant expression, right? This is also an algebraic expression only. Okay. So here 2x plus 3 greater than or equal to 5. Here two algebraic expressions are there. These two algebraic expressions related by inequality symbol. So what is this? This is one inequality. This is one inequality. This is one inequality. These are all inequalities. I hope you learned the definition of inequality. What is the definition of inequality? Two real numbers or two algebraic expressions related by inequality symbol forms an inequality. I hope you understand this. Now you observe what is this chapter name. This chapter name is linear inequalities. Till now we learned what is inequality. Now we will learn what is linear inequality. In 8th standard you learn linear equation in one variable, linear equation in two variable. Those things you learn in 8th standard. right? What is linear expression in one variable? You observe 3x minus 4. What is this? It is a polynomial expression whose degree is 1. So this is known as linear expression. It is a linear expression in one variable. You can observe this 3x minus 4. In this, only one variable is there. What is that? X. 4x minus 5. What is this? This is also linear expression. But this is the linear expression in two variables. You can observe here x, y are the two variables. So linear equation in one variable, linear equation in two variables, you already learned in earlier classes. Okay, here linear inequality means what? In inequality, linear expression is involved, then it forms a linear inequality. Try to understand. In inequality, if linear expression with respect to one variable or with respect to two variables is involved, then it is known as linear inequality. For example, you see here 3x minus 4 is there. Na? 3x minus 4 greater than or equal to 2. You observe this is inequality or not? Yes, this is the inequality. Left hand side part you observe linear expression in one variable is there. So what is this? This is linear inequality in one variable. Okay, you observe this. Is it a linear inequality? No. Here quadratic expression is there. This is just inequality, but this is not linear inequality. Okay, what about this one? This is linear inequality in one variable. If you observe here, what is this? This is linear expression in two variables. So we can easily say that this is linear inequality. You know what is inequality? What is inequality? Between two real numbers or two algebraic expressions, inequality symbol if we kept, then it forms a inequality. In inequality, if linear function in one variable or linear function in two variables is involved, then we say that it is a linear inequality. I hope you understand what is linear inequality. In this chapter, three very important rules are there. Very important. Right? So we are going to learn what are those three rules. Throughout this linear inequalities chapter, three rules are there. They are the main characters of this chapter. Right? Rule number 1. You observe rule number 1. What is this rule number 1? For an inequality, you take one inequality. For that inequality, you add or subtract same real number on both sides. You take one inequality. For that inequality, you add or subtract same real number on both sides. Then sign of inequality remains same. Understand? Don't worry. In case if you didn't understand this, with the help of example, we can understand easily. What I'll do, first I'll take one inequality. For that inequality, I'll add same real number on both sides. This property says that, this rule says that, then sign of inequality remains same. Sign of inequalities remains same means less than remains less than only. Less than or equal to remains less than or equal to only. Greater than remains greater than only, like that. Okay. Here I'll take one inequality. This is true or not? Yes, 10 is greater than 5. This is the inequality. Now I taken one. This is true or not? Yes, it is true. For this inequality, I'll add, look here, I'll add same real number on both sides. You take one real number, add that real number to this inequality on both sides. For example, I'll take 2 and I'll add 2 on both sides. 5 plus 2. What happened? This is the inequality. For this inequality, I added 2 on both sides. What this inequality says, when we add same real number on both sides, then sign of inequality remains same. It means that here greater than is there, na? Greater than remains greater than only. That is what they are saying. Okay? Greater than remains greater than only. Now, this is true or not? Let me check. 10 plus 2. 10 plus 2 is 12. 12 greater than 5 plus 2 is 7. Is 12 is greater than 7? Obviously. As those who completed 10th standard, they can easily say this. 12 is greater than 7. So what happened? I consider one inequality. For that inequality, I added same real number on both sides. Then whatever I got, for that sign of inequality remains same. I hope you understand what is this property. You take one inequality. For that inequality, you add same real number on both sides. Then the sign of inequality remains same. That means you look here, here greater than is there. Na? Here also greater than is there. I hope you got this point. Now I'll take one inequality and I'll subtract same real number on both sides. Then sign of inequality remains same or not. I'll check. This is true. This is true property. Okay. Now I'll take minus 3 less than 10. Minus 3 less than 10. Is it true? Yes, it is true. For this inequality, I'll subtract some real number on both sides. What real number will subtract? 5. I'll subtract 5 to this inequality on both sides. Okay, subtract 5. Minus 3 minus 5. 10 minus 5. Look here, this is the inequality. What I am doing, I am subtracting 5 on both sides. What this property says, for an inequality, if you subtract same real number on both sides, sign of inequality remains same. That means less than remains less than only, greater than remains greater than only. Here less than is there, na? That means less than remains less than only. That is what this rule is saying. Okay, I'll keep less than here. Now I'll check whether this inequality is true or not. Minus 3 minus 5, that is minus 8, less than 10 minus 5 is 5. Is minus 8 is smaller than 5? Obviously, all negative real numbers are less than positive real numbers, right? Minus 8 is clearly less than 5. That means what happened? This inequality is true. Here, what point you need to know? There is an inequality. For that inequality, if we subtract same real number on both sides, sign of inequality remains same. So this is the rule you need to memorize. Throughout this chapter, 3 rules are there. We are going to use all 3 rules very frequently. Now, I'll try to explain this more clearly with an example. Listen carefully. You observe, I consider an inequality x plus 5 is greater than or equal to 2. This is inequality. Moreover, it is linear inequality. Okay, this is the inequality. In this, one unknown thing is there. Unknown variable is there. What is that? X is the unknown thing. Now my question is, I want to find x values which satisfies this inequality. I want to find x values which satisfies this inequality. How to find that x values? To get x values, what I'll do here, x plus 5 is there, na? I don't want this 5. So what you will do? You will erase this 5? No, you can't do like that. So what I'll do, this is the inequality, na? To get x in the left hand side, I'll subtract 5 on both sides. Okay, subtract 5 on both sides. X plus 5 minus 5, 2 minus 5. What happened? This is the inequality. I subtracted 5 on both sides. In this is true or false we cannot say, because in this unknown variable is there. We need to find for what x values this inequality is true. That is what I am doing in this problem. For what x values this inequality is true, that we need to find. Okay. Here, this is the inequality. For this inequality, I subtracted same real number on both sides. You see here, 5, 5. I subtracted same real number on both sides. What this rule says? This rule says that the sign of inequality remains same. That means this greater than or equal to is there, na? Here also we need to write greater than or equal to only. I hope you understand this property more clearly. Okay, I'll write here greater than or equal to. Now you can see this left hand side part, this 5 5 will get cancelled. Left hand side part, what is remaining? X is greater than or equal to 2 minus 5 is minus 3. So whatever real x value you take which is greater than or equal to minus 3, that definitely satisfies this inequality. If you have any doubt, you can take one example. Minus 2. In place of x, you take minus 2 and substitute in this inequality. What you will get? Minus 2 plus 5 is greater than or equal to 2. Minus 2 plus 5 is what? 3. 3 is greater than or equal to 2. 3 is greater than 2. Greater than or equal to is there, na? 3 is greater than 2. Yes, it is true. So this is correct. When I put x equal to minus 2, that is satisfying this inequality. That means minus 2 is solution for this inequality. Not only minus 2, you take any real x value which is greater than minus 3, that satisfies this inequality. I hope you understand this. Here what I am trying to say, this is the one inequality which is true. For that we can add, we can subtract, inequality sign remains same. You observe this one, this inequality is true or not, we do not know. But to find the x values which satisfies this inequality, then also we can use this rule. So what is this rule number 1? For an inequality, if we add or subtract same real number on both sides, the sign of inequality remains same. I hope you understand this. This is very, very important. Throughout this chapter, 3 rules are there. This is the chapter which is having very less theory. Okay, so you must focus on this, right? Now we'll move to next rule. Rule number 2. What is this rule number 2? For an inequality, same like rule number 1 only. For an inequality, if we multiply or divide, last one is add or subtract. Now this is multiply or divide with same positive. This is extra. same positive real number on both sides, then sign of inequality remains same. Here also sign of inequality remains same. Last one also sign of inequality remains same. What is this rule number 2? You take one inequality, you multiply with same positive real number on both sides, then sign of inequality remains same. I hope you understand. I'll try to explain this with an example. You observe here, I consider one inequality, 2 is less than 5. This is the inequality. Now for this inequality, I'll multiply with positive real number on both sides. If I multiply with positive real number to this inequality on both sides, this property says that sign of inequality remains same. Sign of inequality remains same means greater than remains greater than only, less than remains less than only. Okay, you observe 4 is the positive real number. For this inequality, I'll multiply with 4 on both sides. Okay, multiply with 4 on both sides. What this rule is saying, this is the inequality. If we multiply both sides with positive real number, inequality sign remains same. That means this less than remains less than only. So I'll write less than. Now let me check this inequality is true or not. 2 into 4, that is 8. Less than 5 into 4 is 20. Right? 8 is less than 20. Is it true? Yes. 8 is smaller than 20. What happened? This is the inequality which is true. For this inequality, if I multiply with some positive real number on both sides, then sign of inequality remains same. Less than remains less than only. I hope you understand this. Now I'll take one more example. You observe this inequality. 5 is greater than 3. Yes, 5 is greater than 3. It is clearly true. For this inequality, I'll divide with same positive real number on both sides. If I divide with same positive real number on both sides, sign of inequality remains same. I'll check whether it is correct or not. What I'll do, I'll divide with 2. Divide with 2. 2 is the positive real number. Now, if I divide with positive real number on both sides to this inequality, this rule is saying sign of inequality remains same. That means greater than remains greater than only. So 5 by 2 is greater than 3 by 2. Now I need to check whether it is true or not. 5 divided by 2. 5 divided by 2 is what? Half of 2 is 2.5. Greater than 3 divided by 2. Half of 3 is what? 1.5. Right? 2.5 is greater than 1.5. Is it true? Yes, 2.5 is greater than 1.5. What happened? This rule is working very fine. This rule you need to memorize. This is true. To explain this rule, I am taking all these examples. Okay. You take one inequality. For that inequality, if you multiply or divide with the same real number on both sides, then sign of inequality remains same. Rule number 1 also sign of inequality remains same. Rule number 3, it changes. So how we use this rule while doing exercise problems? I'll take one example. Here 2x less than or equal to 4. An inequality is like this. To find the x values which satisfies this inequality, I can use this rule. Okay. Here 2x less than or equal to 4. This is the inequality. From this inequality, I want to find x. So I am trying to get x in the left hand side. To get x in the left hand side, I'll divide this inequality both sides with 2. 2 is a positive real number. Okay, you divide with 2 on both sides. 2x divided by 2 is less than or equal to 4 divided by 2. You observe, this is the inequality. This inequality I divided with 2 on both sides. 2 is the positive real number. Now what this property says, this rule says that for an inequality, if you divide with a positive real number, then sign of inequality remains same. That means this less than or equal to remains less than or equal to only. So you can observe this left hand side part, this 2 will get cancelled. Right hand side part 4 divided by 2 is 2 only. So what you got? X is less than or equal to 2. That means you take any real x value which is less than or equal to 2 that satisfies this inequality. So here you take one real number which is less than 2. Suppose you take x equal to 1. Substitute x equal to 1 in this. 2 into 1 less than or equal to 4. What you will get? 2 less than or equal to 4. 2 less than 4. So this inequality is true. Like that, you take any real x value which is less than 2, that definitely going to satisfy this. So I hope you understand this rule number 2. Now we are going to learn rule number 3. That is hero of this story. So that is very, very important one. Third one. Rule number 3. What is this rule number 3? For an inequality, if I multiply or divide with same negative real number, Last one is positive real number. This is negative real number. If we multiply, divide with same negative real number on both sides, then sign of inequality changes. Sign of inequality changes means less than changes to greater than changes to less than. Okay, I'll try to explain this with examples. You observe here, I'll take one example like minus 3 is less than 5. Is it true? Minus 3 is less than 5? Yes, it is 100% true. What I'll do, this is the inequality. Now, for this inequality, I'll multiply with some negative real number. I'll take minus 1. Minus 1 is negative only now. Multiply with minus. Minus 3 into minus 1. 5 into minus 1. This is the inequality. I multiplied this inequality with minus 1. As per this property, if we multiply with negative real number on both sides, then sign of inequality changes. Here, less than is there now. Less than changes to greater than. This is what this property is saying. Now I need to check whether it is true or not. Okay, 3. Okay, 3 is greater than 5 into minus 1 is minus 5. Look here. I got that 3 is greater than minus 5. We know that all positive real numbers are greater than negative real numbers. That means what happened? This is the inequality with the less than symbol. When I multiply this inequality with a negative real number, then sign of inequality changes. You can observe here less than is changed to greater than. This is what this property says. I hope you are understanding. You observe 5 is greater than 3. Is 5 is greater than 3? Yes. 5 is greater than 3. For this inequality, I'll divide with some negative real number on both sides. This is the inequality now. For this inequality, if I divide with this negative real number, what this property says? This property says that sign of inequality changes. Here greater than is there now. Greater than changes to less than. So here 5 by minus 2 is less than 3 by minus 2. Now I need to check this inequality is true or not. 5 divided by minus 2, that is half of 5, that is minus 2.5 is less than 3 divided by minus 2. 3 divided by minus 2 is minus 1.5. Now minus 2.5 is less than minus 1.5. Yes, it is true. 3 important rules are there in this linear inequality, and this third rule is hero of this story. Right? If you understand these 3 rules, then you can do these exercise problems very easily. It's a cakewalk. First exercise of linear inequalities is a cakewalk if you know these 3 rules. Creating these videos take so much time. In case if you like this video, please drop a like and share this video with your friends. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Take care. Bye-bye.